Okay, today we're going to talk about logistic regression. And it's a model which you use when you have a binary outcome that has only two possibilities. And we're going to use gender, and we're going to use the CDC2 data frame. This is a version of CDC that I cleaned, removed some oddball observations, and added a few new variables, okay? So the first step is to load the data. So we'll go ahead and do that. Oh, of course you'll have to download the data from Moodle first. Okay, so you can pause the video while you get that done, and then come back and we'll proceed. Okay, so to get the packages we need the tidyverse as usual. We always need the tidyverse, and we need PROC, and I'm certain you don't have PROC installed, so go ahead and get PROC installed, and then library both the tidyverse and PROC, and pause the video while you get that done, and then come back and we'll talk some more, okay? Okay, so I assume you've got everything done, and we can proceed. And we've got the value gender, which has two values, M and F, so it's suitable. It's a binary variable. And you could just feed gender in as the dependent variable in this model, but that's not a good idea because it's really easy to get confused about which value you're taking as the target, and it's the one that has the highest value. So what is best to do is either to create a 0-1 variable or a true-false, and either you're going to predict 1 or you're going to predict true. So I'm going to predict is male, and that'll work. It'll be clear that the probability that you produce from the logistic regression is the probability that this observation is a male. So create that Boolean variable, and then do a table of is male and gender to make sure that you've got it right. And pause the video for a minute while we get that done. Okay, you're back. Let's go on. So here's the step. It's a mutate. CDC is CDC2, and then mutate is underscore male is equal to the Boolean expression gender is equal to M. And we see that it is true for males and false for females. Okay. Now, later on, when we get into serious modeling, we would split the data into train and test, and we would not use the data on which we estimated the model to test it. Today, we're just going to do the simple thing, and we're going to use the entire data set for both training and testing. Okay? So we're ready to do a logistic regression model. And the first model, Model 1, we're only going to include a single variable, that's height. And it's very similar to what you would do with a model using LM, but we're going to use GLM instead. And then to do a logistic regression, you have to include the argument family equal binomial in the call. Okay, so go ahead and do that, and then we'll come back and we'll talk some more. Okay, you're back. I guess you've got that done. So here it is. We're predicting is male on the basis of height. The data is CDC2, and the family is equal to binomial. And then we do a summary of model 1. And the only thing that I'm interested in this summary really is the sign of the coefficient of height. And notice that it's positive. That's important because it means that the model is predicting that a greater height increases the probability that a person is male. And we know that that is true. So our model is working correctly. Okay. We also would worry about the t-statistics, but those are so minuscule that we have no concern whatsoever. All you'd look for is an absolute value of the z value being either greater than 2 or less than -2, and we got that very, very, very clearly. Okay, so on we go. So I want to create predicted probabilities for the observations in CDC2 using model 1. Include type equal response to get probabilities as predictions. And call this vector probs. Okay, so please go ahead and do that. Pause the video for a few minutes while you get that accomplished, and then we'll come back and we'll talk some more. Okay, you're back. Let's go on. So probs is predict using model 1 and data CDC2, and it says set the type equal to response, and that is what means that we're going to get a probability rather than a log odds in the predictions. Okay. So, okay, you want to predict that an observation is male or not. And what you've got at this point for every observation is the probability that that observation is a male. But to make an actual prediction, you have to decide, well, should you call a person male if the probability is greater than 80%? Well, I think the sensible thing to do is use either of two values, either 0.5, which is what kind of the default is, or you could set the probability as being the fraction of males in the data set. Okay? So we're going to do that. We're going to predict the mean value, use the mean value of is male as the threshold probability, and use that to get a vector of predictions called preds. So you use probs to produce preds. Okay, so stop the video and do that. Okay, you're back. Let's go on. So here we are. The threshold is the mean of CDC2 is male, and the preds is equal to the probs is greater than the threshold. So now you'll have a vector of the probs, which will be either true or false, to tell you whether you've concluded that each observation is either male or female. Accuracy. Okay, now we can compute a value of accuracy by comparing preds with CDC$2 is male. So go ahead and do that. Stop the video, of course, while you're doing it. Then come back and look at what I've done. Okay, you're back. Let's look. Accuracy is the mean value of the logical expression that preds is the same as CDC2 is male. And here is our value of accuracy. It says you are correct 85% of the time. Okay. So the value of accuracy depends on both the model and the chosen threshold. That is, the value of accuracy depends on a choice that you make after you estimate the model. And the standard way of really looking at the quality of the model as a whole is to look at the area under the curve, which the curve, of course, is the receiver operating curve. And hopefully you learned about this in the data camp course. So go ahead and implement those steps. And I will pause the video. You will pause the video and do this, and then come back and we'll talk some more. Okay, you're back. So we compute the ROC using the function ROC, lowercase, and we have to feed in two things: CDC2 $is_male and probs. And we plot the receiver operating characteristics curve, and it looks like this. And the overall quality is the area under the curve, which is, in this case, 0.9233. Okay? So the last exercise, well, it's the last exercise before the last exercise. Put all the steps above into a single block of code. Then use the code to examine another model. And for the other model, we'll just add smoke 100 to height. And what happens to our accuracy and AUC. Okay, so that'll take you probably several minutes, because you got to pull all that code into one block and then add the smoke 100 to the list of independent variables. Okay, so let's stop the video and get that done, then come back. Okay, you're back. So here's what we've done. In GLM, we've got smoke 100. Everything else is the same. And you notice that both things have a positive coefficient, because males are taller and have a tendency to smoke more. So we've got the right coefficients on these, the right signs on the coefficients. Okay, then we do all the other steps: compute probs, assign a threshold, get preds, then compute accuracy, and it's 0.845. Not much different. Then we compute the ROC and the AUC, and really very minimal difference. We went from 0.9233 to 0.9247. So it's a little bit better, but nothing really to write home about. So try various combinations of variables and see if you can improve on the AUC. Just fiddle with this. There's lots of variables that you could use in the data frame CDC2. Okay, so that concludes my lecture, my video lecture.